So the big picture for this lesson is the fundamental theorem of algebra. The fundamental theorem of algebra says if f of x is a polynomial of degree n, where n is greater than 0, so you have a polynomial with a positive degree, then the equation f of x equals 0 has at least one root in the set of complex numbers. So if you have a degree greater than 0, you're going to have at least one root in the set of complex numbers. But you can extend that to say these other things as well, and these are the important ones for what we're doing. The degree of a polynomial equation is the same as the number of solutions of that polynomial equation, and that includes complex numbers. So if you have an x to the fourth polynomial, there are going to be 4 solutions. And that does include repeats, because you have multiple factors. Like let's say you have x plus 2 times x plus 2 equals 0. X equals negative 2 is the solution, but it's just repeated. So this number, this 4 solutions, includes repeats. The second one, every polynomial that has a complex number solution also has its conjugate as a solution. So if 3 plus I is a solution, then 3 minus I is a solution. So that means you need to be looking for pairs when you're looking for complex number solutions. And fortunately, you find complex number solutions by using the quadratic formula or completing the square anyway, so those should appear automatically because you have a plus or minus in each one, because it's negative b plus or minus the square root all over 2a. And this is the discriminant in here. But because of this plus or minus, that means you're going to have the conjugates. So you're just going to be using this idea and all of the techniques that you've learned in the lesson so far for finding zeros, mostly by factoring. And you're going to be finding all the zeros for the polynomials. That's the big picture.